Propagation of light. In this lesson, we are going to learn propagation of light. We see many things around us. What makes it possible for us to see them? At night, when we switch on the light, we can see the books on the table, the clock on the wall, the clothes on the stand, but we cannot see anything if the lights are off. We say that light makes things visible to us. Can we see the entire book when the light from a table lamp falls on it? No. We only see those parts on which the light falls and gets reflected into our eyes. You might have seen a beam of sunlight when it enters a room through a narrow opening on a hole. You may have also seen beams of light from the headlamps of scooters, cars, and engines of trains. Similarly, a beam of light can be seen from a torch. Some of you may have seen a beam of searchlight from a lighthouse or from an airport tower. Light travels along a straight line. Let us perform an activity to prove that light travels along a straight line. In this activity, we look at a lighted candle first through a straight pipe and then through a bent pipe. When we try to see the lighted candle through straight pipe, we can easily see the candle flame. But when try to see the lighted candle through a bent pipe, we are not able to see the candle flame. This activity shows that light travels along straight lines. How can we change the path of light? What happens when light falls on a polished or a shiny surface? Now let us perform an activity to prove that light travels along a straight line. In this activity, we look at a lighted candle through 3 cardboard with holes arranged in a straight line. We can easily see the candle flame. When 3 cardboard with holes arranged not in a row, we are not able to see the candle flame. This activity shows that light travels. This is called the linear propagation of light. The shadow cast by a point source of light. Let us explain this with the help of an activity. Take a candle, a torch as a source of light. Place a piece of cardboard with a hole in its center in front of a torch. Now the light can be seen emerging from the fine hole, O. Such a source of light is called a point source. At a distance of about 1 meter in front of the cardboard, place an upright screen. Between the source O and the screen, suspend a ball PQ. Now observe the shadow AB of the ball PQ. The rays OP and OQ from the point source pass the ball just touching it at P and Q and fall on the screen at points A and B respectively. However, no rays reach the part of the screen between A and B. Hence, this part remains dark. This is the dark shadow called the umbra. What happens if the screen with the hole is removed? We do not have a point source anymore. This is called an extended source. What is the nature of the shadow caused by an extended source? In the figure alongside, MN is an extended source. PQ is the ball placed in front of it. As a result of the extended source, we see a shadow which has 2 parts, a faint part and a dark. The part BC, which is fainter, is called the penumbra, while the darker part AD is called the umbra. Keeping the distance between the extended source and the ball, the flame moves the screen further away from the ball. Observe the shadow of the ball. As the screen moves further and further away, the umbra becomes smaller and smaller till finally it completely disappears. We saw how and when there is a source of light, an object casts a shadow on the screen. Eclipses. The sun is the largest source of light in the sky. The planet Earth and its satellite, the moon, are also in the sky. When the sun, moon and earth happen to come in a straight line, we say that an eclipse has occurred. If the moon comes between the sun and the earth and they are in a straight line, the shadow of the moon falls on the earth and we say that a solar eclipse has taken place only on a new moon day. The solar eclipse may be total or part, and if the earth comes in between the sun and the moon and the three are in the straight line, the shadow of the earth falls on the moon and a lunar eclipse takes place. Naturally, a lunar eclipse takes place only on a full moon day. It may be either total or partial. Summary. Light travels in a straight line. There are two types of shadow, the umbra and the penumbra. When the earth is between the sun and the moon, we see a lunar eclipse. And when the moon is between the sun and the earth, we see a solar eclipse. So that is all in this topic, student. Keep learning.